Hi there. So today we're going to look at some more BBC optimization techniques. Initially we're going to look at the GOSUB versus PROC command. Obviously go-to is definitely a four-letter word when it comes to basic programming. GOSUB is pretty ubiquitous. You kind of have to use GOSUB, and that's fine. On BBC Micro there was the offering of a procedure which is a lot cleaner. It's a lot more modern, really, in terms of programming. When you do a GOSUB, you branch to a location of a program based on its line number, and that's all fine. And then you do a return, and that's it. Great. But when the programs get large, it quickly becomes a problem of remembering line numbers and having these big lists you've got to write out of line numbers and all that nonsense. With the procedure, you can actually have a proper name, and so it's a bit more like a grown-up programming language, insofar as it's easier to debug and easier to understand, and you haven't got to worry about line numbers. Now, the interesting question though is when you're talking about squeezing every last cycle out of a BBC basic program, is there an advantage to use a PROC versus a GOSUB? So let's do some testing. So here I've got a very simple program to test that. We are looking at comparing a very simple procedure. So on line 330, we're just adding to an integer value, adding one to it in a loop. That's fine. So in this case, we're going to go sub to 330, or do that and then a return. We'll do the same thing but using a proc. So we got procedure increment A, and that does the same thing. So it actually looks better, so it looks a lot cleaner. Obviously this is not very transportable to other versions of Basic. If your version of Basic on some obscure system somewhere doesn't support proc, and most of them don't, then you can't use it. But in the case of the BBC Basic, certainly the modern implementations of it, and right back in the day on the original BBC Micro, this potentially can save both confusion and potentially cycles. Well, let's see whether that is true. So when we run it within Windows, we get that. So that's encouraging. So there is obviously a difference there. Now, running it in this environment is a little artificial. We always got to transpose this and push it into a BBC emulator to see whether those performance benefits are actually real. So let's do that now. And run it. Tension mounts. Okay, so there is a difference. So you can see here we've got on the GOSUB time 348, on the procedure time 321. So actually it's not just about the prettiness of the code, the maintainability of the code, not having to worry about line numbers, all that other nonsense. It's actually faster, so that's really good. That's actually really encouraging. They are very useful things. I don't use them as much as perhaps I should, but then I'm always keeping an eye on the transportability of that code. So if you make heavy use of procedures, especially when that procedure returns a value which you can actually have, so you can use that, essentially create your own functions which return a value, then there's no direct analog with GOSUB. So you'd have to set a global variable as the return and whatever. So you have to be a bit careful. If you're making transportable code, then perhaps you steer clear of this too much, or you do it in such a way that you can have a standard return variable which you can use every time. But I don't know, so it could potentially get messy. But anyway, on this initial test, that's a reasonable advantage in terms of performance. If it's just targeting BBC, then there's really no reason why you wouldn't use that. It's easier to read, easier to maintain, and it's faster. So that's great. On the second test, I'll just reset this emulator. We've got a test of local versus global variables in procedures. So within procedures you can specify, you can define a variable as being local. If it's local, then it is only valid within that scope. So we have a procedure here called increment local, and what that's doing is it's defining a local instance of a percent here. So that's an integer value, but it's local, so it's not the built-in integer values. It's not a global variable. In the other procedure, where is it? Inc global, then that is using the global variables. Now, this is a little bit of a cheat here, because when you define it, on definition, it has the default value, which in this case is 0. So I'm having to do the same thing here. So if you're using a global variable in a local context, then you need to make sure your start conditions are right. So this may skew the tests a little, because obviously if you are using a local variable, it will default to 0, whereas a global variable won't. So you'd get inconsistent results. Now, if you're using this variable somewhere else, perhaps I should have used a full next loop or something where you automatically initialize the start value of it. But we might get some insights into what's happening. So if we run this, then there's no obvious difference. Now, it might be that we need to turn the Q value up. In fact, we might as well do that and have a look. So when it's running on PC, it's really hammering it. Well, yeah, there may be a slight advantage to using local variables. Okay, not 100% convinced by that. So, as with the other test and all the other tests we've been doing, let's copy and paste that into an emulator and see what it's like on, in quotes, a real BBC. It's actually worse. So when I was doing some testing on this, it's kind of, in some ways, kind of surprised me. In other ways, maybe not. I don't know, because when you're reserving space for a variable, then that variable that we're talking about, in this case, the a% variable, that is not the global integer value. The resident integer value is not. It's another integer variable. So of course, when you think about it, what it's got to do is it has to define and reserve space on the stack for that particular value. So it's got to do some work first off before it can even start using the variable. So local variables, yeah, very useful from certain perspectives of keeping things modular. If you're running a procedure which has lots of variables and you're reusing variable names, you know, like I and J and all sorts, then perhaps there is a case for using a local variables. That modular code could then lift and shift easily into another program, no problem. But in this particular case, there are obviously performance disadvantages in having local variables. Now, in the scheme of things, they may not be that big, those disadvantages. Some, you know, relatively minor performance hits potentially, but as things scale up and when we want to try and squeeze every last drop of performance out of it, perhaps there is still a case for using either using a global variable or even using the resident integer variables. In that case, we have to set it to a known value, but hey, you know, for most of our code we are doing that anyway. If you've got a for loop with an I in it, then you are setting that initial condition every time you use it, every time you go around the loop. So you kind of got to do it anyway. So what's the takeaway? Definitely use procedures. If you're sticking to only BBC Basic dialect, then use procedures. And I'll do some other testing on return variables for that on another video. And in the case of local variables, yeah, if it's a complicated procedure, and there's you want to be safe in terms of not having that interfere with other parts of the code and whatever, then great, you could use locals. But you have to be mindful that there may be a performance penalty in doing just that. Thanks a lot. Cheers.